Unit 4, Lesson 3, Tests for Parallelograms. Today we're going to be looking at some problems and determining if they are parallelograms or not. We have 4 theorems to review through at the beginning. So Theorem 2.9, Theorem 2.10, Theorem 2.11, and Theorem 2.12. These 4 theorems will help us with determining whether or not our examples are parallelograms. Let's take a look at example 1. So identify parallelograms. Determine whether this quadrilateral is a parallelogram, and we want to justify our answer. So if we look at it, we have opposite sides have the same length. So yes, this is a parallelogram. This is a parallelogram. And the reason, if opposite sides are congruent, then it is a parallelogram. And as we said, this is 12, so opposite sides are congruent. This is 5, so opposite sides are congruent. Let's take a look at example 2. So the top of the eraser appears to be a parallelogram. Find the value of x and y so that the sides of the eraser is a parallelogram. So let's go ahead and start working on that. So we want to start off with finding x. And then we also want to find y. So if it is a parallelogram, then opposite angles will be equal to each other. So we have that 7x equals 56. So these two will equal each other. Divide by 7. X equals 8. And then here, opposite are going to be equal to each other. So we have 4y minus or plus 4 equals 5y minus 26. So I'm going to start off with subtracting 5y from both sides, minus 5y minus 5y. So that way I can get y on one side. That gives me negative y plus 4 equals negative 26. Subtract 4 from both sides. That gives me negative y equals negative 30. Divide by negative 1 because you don't want a negative in front of your solution. So you get y equals 30. So y equals 30 and x equals 8. Now let's take a look at example 3. We want to identify the parallelogram on the coordinate grid. So we're going to use our midpoint formula that we did at our launch to find the value. So we're going to start off with finding the midpoint. Of GJ. So again, our midpoint formula is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So our x1 is going to be 4. Our x2 is going to be negative 2 divided by 2. Our y1 is going to be 2. Our y2 is going to be negative 1 divided by 2. So this gives me a midpoint of 1 and 1/2. So from the other midpoint, I want to get the same coordinate out. So find the midpoint. So I did GJ, now I'm going to do FH. Doesn't matter which one goes first, I want to end up at the same point though. If I'm not in the same point, then we're not bisecting. So again, our formula for midpoint is M x1 plus x2 divided by 2, y1 plus y2 divided by 2. So our x1 value is negative 2 plus 4 divided by 2. And then our y1 value is 4 plus negative 2 divided by 2. So work this out. Negative 2 plus 4 is 2. 2 divided by 2 is 1. Negative 4 plus, or 4 plus negative 2 is 2. 2 divided by 2 is 1. Uh-oh, I have 1 and 1/2. I have 1 and 1. Not the same. Coordinate. So not a parallelogram. So review through the 4 formulas that we have at the theorems that we have at the beginning, summarize your understanding, and then use these problems to help you out with the practice.